There is a business district in Shenzhen called Qianhai, where something does not add up. Dozens of glass towers packed with offices, shops, hotels, and thousands of people moving through them every day of a brutal southern China summer. Look closely at the outside of any of those buildings and you will not find what you expect. No window units, no compressor boxes clinging to the walls, none of the metal cages full of humming machinery that cover the outside of nearly every building on the planet. And yet step inside and the air is cold, properly, comfortably cold. So if nothing on the outside of these buildings is making cold air, where is it coming from? The real answer sits several stories beneath the pavement, inside a facility most people who work in that district have never even heard of, let alone seen. But that hidden machine is only the final chapter of a much longer story. Getting to this point took China more than a decade of watching its cities nearly break under record heat, and deciding that a slightly better version of the air conditioner was never going to be enough. What they built instead touches everything from the clouds above the country to a small chip pressed against a person's neck. Stick around, because by the end, you will understand exactly how an entire district can stay cold without a single traditional air conditioner in sight. Let's start with the moment that made this whole rethink necessary. Rewind to the summer of 2022. That was the year China endured a heat wave unlike anything in its recorded history, one that dragged on for more than 2 months and shattered temperature marks that had held since national weather records began in 1961. The Yangtze thinned out so badly that dry, cracked riverbed became visible in places where boats used to pass. Hydroelectric stations across Sichuan, which normally send power to cities over 1,000 kilometers away, saw their output crash because there was not enough flowing water to spin the turbines. Entire factories were told to close. Not from a labor dispute, but because there was not enough electricity left to run production lines and keep homes livable at the same time. None of this reads like an unlucky season. It reads like a system reaching its limit. Air conditioners run on electricity, and a severe heat wave cripples electricity supply, which means the hotter it gets, the harder the grid gets pushed, and the closer the whole system comes to failing right when people need it most. So rather than simply adding more cooling capacity to a system already buckling, engineers went looking for ways to pull heat out of the equation altogether, starting in the least likely place imaginable, the clouds themselves. During that same crisis, Chinese authorities turned to a tactic that would sound made up if it were not fully documented on state television. They set out to manufacture rain over an area roughly the size of a small country. China operates the largest cloud seeding program on Earth, using silver iodide, a compound whose crystal structure mimics ice closely enough to trick water vapor into gathering around it and freezing. Once enough ice crystals cluster together, gravity takes over, and they fall as rain, coaxing precipitation out of clouds that might otherwise have drifted past a parched city without releasing a drop. Delivering the chemical is the theatrical part: rocket launchers, anti-aircraft weapons repurposed to fire slim canisters skyward, manned aircraft threading through storm layers, and during the worst of 2022, military-style drones as well, staying airborne for hours over Sichuan and releasing dozens of silver iodide charges across thousands of square kilometers of sky. Within days, some areas that had been rationing water were dealing with the opposite problem. Here's the catch, though. This is not a switch that summons storms out of clear sky, and it cannot dramatically outperform whatever moisture already exists up there. But nudging a reluctant cloud into releasing its water does double duty. It knocks down the air temperature immediately, and it replenishes the reservoirs that the rest of the country's power and water systems depend on. The next idea did not come from a drone command center at all. Builders figured it out roughly 1,000 years before anyone had a word for climate control. Long before electricity existed, people in parts of China were already living comfortably through summers just as brutal as today's, inside homes with no fans, no vents, and no mechanical parts whatsoever. Step inside one of the old courtyard homes still standing in the Huizhou region, and something unusual sits at the heart of the structure. Not a hallway, but a gap. A tall, narrow shaft cut straight through the center of the house, open to the sky above. Locally, it is called a tianjing, a sky well. It looks decorative, but it turns the entire house into a passive cooling system, using nothing but temperature difference and gravity. Warm air always rises. The rooms surrounding that central shaft sit low and shaded, protected from direct sunlight, which keeps the air pooling near the floor cool and dense. Meanwhile, heat building up elsewhere in the house drifts upward and slips out through the opening at the top, pulling fresher, cooler air up from the rooms below. Interior readings inside surviving Skywell homes show the air staying noticeably cooler than conditions outside on a hot afternoon, sometimes by several degrees. What turns this from history into the future is that engineers realized the courtyard itself was never the essential part. The moving column of air was. In Guangdong, a 68-story tower now uses internal vertical shafts to channel air, borrowing the Skywell's basic trick without needing an open courtyard at all. Old solutions were not primitive. They simply solved problems that later generations outsourced entirely to machinery. And one of the biggest problems modern cities never solved is sitting directly under everyone's shoes. That dark pavement under your feet is doing more damage to your comfort than almost anything else in a city. Standard black asphalt reflects only 5 to 10% of the sunlight that lands on it, meaning nearly all the rest gets absorbed into the material. By mid-afternoon on a scorching day, that surface can climb past 60 degrees Celsius, hot enough to burn skin on contact. And unlike a rooftop, a road stores that heat and releases it slowly well into the evening. A big reason a city can feel hotter at midnight than the fields just outside its edge. Researchers call this the urban heat island effect, and roads are one of its biggest contributors. Cities including Guangzhou and Shenzhen tackled it head-on by repaving major roads with cool pavements, reflective coatings that bounce sunlight back skyward, layers that slow how quickly heat travels into the material, and porous surfaces that hold moisture so heat can escape through evaporation. The same principle behind the fine mist you sometimes see drifting over a crowded sidewalk. A spray so light the droplets vanish before touching the ground, dropping street-level temperatures by 5 to 8 degrees Celsius using barely any electricity. Testing on these coatings has shown surface drops of 7 to 14 degrees Celsius compared to plain asphalt under identical sun. Apply that across an entire road network, and you are lowering the baseline temperature of the whole urban area, right when it matters most, after dark. The next innovation tackles something that sounds physically impossible: a coat of paint that cools a building using nothing from the sun at all. Roll a coating onto a roof, and the building underneath becomes cooler, with no wiring, no power draw, and no moving components anywhere, even sitting directly under harsh midday sun. So how can something with zero energy input end up colder than the surrounding air? The trick is that this coating is not battling the heat head-on. It is redirecting that heat somewhere else entirely. The science is called passive radiative cooling, and it pulls off two separate tricks simultaneously. First, the surface bounces back nearly all the sunlight striking it, so the building barely absorbs any solar energy to begin with. The second mechanism is less intuitive. Every object with warmth releases some of that heat as infrared radiation. Ordinarily, that radiated warmth bounces between nearby surfaces and gets reabsorbed almost immediately. But there is a narrow slice of the infrared spectrum our atmosphere lets pass through freely, almost like a window straight out of the planet. Heat radiated at that exact wavelength skips past the atmosphere and escapes into deep space, a place sitting only a few degrees above absolute zero. This coating is tuned to release its heat within that escape window, turning empty space itself into a bottomless heatsink that never sends a bill. Because the surface loses warmth faster than sunlight can replace it, the coated material can end up cooler than the surrounding air even in direct light. A research group in Hong Kong turned this into a commercial product, and rooftops treated in direct sunlight have shown indoor temperature drops of roughly 10 degrees Celsius, translating into cooling energy reductions approaching 40%. Now scale every one of these ideas up from a single rooftop to an entire district full of towers, and you land right back where this story began, at that hidden facility underneath Qianhai. Picture how a typical business district handles cooling. Dozens of separate buildings, each bolted with its own fleet of air conditioning units, every unit running its own compressor, leaking refrigerant, drawing its own slice of electricity, duplicating the exact same fight against the exact same heat over and over across an entire skyline. Planners in China looked at that and asked a fairly obvious question nobody had seriously pursued. Instead of thousands of small, inefficient machines each fighting alone, why not build one massive, highly optimized system to serve everyone at once? Sounds simple when you say it like that. that, actually building it is where things get serious. That concept is called district cooling, and in the Qianhai zone of Shenzhen, it operates on a scale that is hard to visualize. Several floors down sits a facility a visiting reporter once compared, not to a piece of equipment, but to an entire factory floor, packed wall to wall with pumps, pipework, and chillers across an area roughly the footprint of a football field. Its sole purpose is producing chilled water at industrial volume, then sending it through insulated underground piping into building after building throughout the district. Each tower connects into that network the way a home connects to the municipal water supply. Cold water arrives, absorbs heat from inside the building, and makes the return trip so the plant can chill it again. One shared, extremely efficient cold source stands in for what would otherwise be thousands of scattered, wasteful ones. A setup like this can cover roughly 3 square kilometers of buildings, and the Qianhai facility reportedly saves close to 130 million kilowatt-hours of electricity annually, comparable to leaving 16,000 tons of coal unburned and keeping roughly 130,000 tons of CO2 out of the sky each year. That is the literal answer to how an entire district gets cooled without a single traditional air conditioner. Still, a plant buried underground cannot help the one person this whole system exists to protect. Somebody standing outside with nowhere to hide from the sun. Everything so far cools a space. None of it addresses the person simply standing still, waiting for a bus, walking down a sidewalk with nothing overhead but sky. Conventional wisdom says you cannot cool open air. China decided to test that anyway. At bus shelters, subway entrances, and busy plazas across the country, freestanding cooling units now push streams of chilled air directly into public space, meeting people where they already are. Many of these units run entirely on solar power, and the logic is almost too clean. The hottest hours of the day are also the hours when solar panels generate the most electricity, so the same sunlight causing the discomfort ends up powering the fix. Beyond these public installations sits the smallest scale of all, and arguably the one now touching the most lives day to day. A curved band worn around the neck, resembling headphones, quietly directing airflow across bare skin. A handheld fan fitted with a tiny water reservoir, releasing a fine mist into its airstream. Vests and jackets stitched with battery-driven fans, pushing a continuous current of air across the body. These wearable coolers have moved from niche gadget to daily habit for enormous numbers of people in a remarkably short window of time. The neck-worn versions stand out most. The better models press a compact metal plate against the back of the neck, powered by a solid-state cooling chip underneath. Once current flows through it, one face turns genuinely cold, cold enough to draw heat straight out through skin located right above one of the body's major surface blood vessels, helping bring down core temperature more broadly. Given how much of daily life in China happens outdoors under extreme heat, a device that keeps someone's body temperature within a safe range is closer to a safety tool than an accessory. Heat stroke remains a genuine killer every summer, and an affordable cooling device that ordinary people can keep on hand and flip on the instant conditions turn dangerous provides protection that no buried plant or a stretch of treated pavement could ever match at that personal A level. Step back and look at the whole picture. China never set out to build a stronger air conditioner. It built a layered defense against heat that operates at every scale simultaneously. Up in the atmosphere, drones and rockets nudge stubborn clouds into releasing rain. On rooftops, a coating quietly discharges heat into space around the clock. Down at street level, resurfaced roads stop soaking up nearly as much solar energy in the first place. In architecture, a 1,000-year-old airflow trick has been scaled into modern skyscraper design. Underground, a single industrial facility the size of a football field replaces thousands of individual machines through a hidden network of pipes. And at the most personal scale, a small chip pressed against someone's neck keeps their body temperature in check while they move through the world. Combine every one of those layers, and you get an outcome no single air conditioning unit, no matter how advanced, could ever produce on its own. A city that keeps functioning through heat extreme enough to otherwise threaten its power grid and its people. Most places still treat heat as something private, solved room by room with a machine mounted on a wall. China began treating it instead as shared infrastructure, engineered deliberately across an entire city the way roads or water systems are, stretching from the sky above down to a device someone slips into their pocket. As heat waves grow longer and more severe nearly everywhere on the planet, do not be surprised if pieces of this exact approach show up somewhere close to home before long. If this changed how you look at the sidewalk under your feet or a roof coated in white paint, hit that like button and subscribe so you do not miss what we cover next. Turn on notifications too, because heat waves are only getting more extreme, and we are going to keep tracking every new system China rolls out to fight them. Now here is what we want to know in the comments. Out of everything covered here, which piece would you actually want installed in your own city? The hidden plant nobody notices? The coating that releases heat into orbit? Or the small cooler worn around the neck? Drop your answer below, because a country that can keep an entire district cold without a single traditional air conditioner has clearly figured out something the rest of the world has not caught up to yet.